This is a demo of modelling a DAS array inside an office building by request. So here we have an office building as a GLB model, and if I put on the wireframe and I select these transmitters, you can see that I have 3 transmitters here on this side of the building which I can place on different floors. So I've got one here, one upstairs, one downstairs. I'm going to model this at 10 centimeters using the 3D API on Soothsayer 1.8, and I'm using 5 reflections and 10 centimeter resolution. So I click the button here, job is sent to the API, GPU is now doing its thing, and it will then present the layer back into Blender like so. So we've got RF coverage now. I've just taken off the wireframe, and what we can do is actually hide the office building first of all. So if I want to look here and uncheck that collection, I can now fly around from outside and have a look at the coverage from an external point of view, and I can see a couple of rooms here which have got patchy coverage, ironically right next to where some of the antennas are. Okay, if I want to go inside the building, switch on the building layer, and we can just go ahead and fly into the building through the little balcony here, and you see an open plan building here. The reason it's blotchy here is because we're tracking the phase. There's a lot of multipath and reflections going on inside this glass monstrosity, and we've got these stairs which we've modeled coverage on. Going down to the ground floor, you can see a room with bad coverage here, a room with mixed coverage, so good and bad, and a room with no coverage. This sort of vertical model is very challenging for 2D planning software to do because it works on a floor plan concept, and so when you've got an open architecture like this, it's very challenging without doing a walk survey in order to validate the coverage, or at least plan for it.